Tonight I want to take you somewhere special, somewhere at the very edge of what we can imagine, to a place where the familiar rules of existence begin to bend and whisper different truths. We're going to explore one of the most captivating questions that physics has ever offered us. What happens to time itself when you approach the ultimate speed limit of the universe, the speed of light? It's a question that might sound like pure science fiction at first, something from a movie or a dream, but the more we look at it, the more quietly intriguing it becomes, the more it reveals about the hidden architecture of everything around us. As you settle in wherever you are right now, perhaps in your bed, maybe on a couch or somewhere else entirely comfortable, I'm curious about where in the world you're listening from. What corner of our planet are you resting in tonight? And what time is it there in your particular slice of this spinning world? Is it late evening, with stars just beginning to appear? Or perhaps it's the deep middle of the night, when thoughts turn naturally to the mysteries that daylight tends to hide. Wherever and whenever you are, you're invited on this gentle journey through space and time. And if you find yourself drifting along with these ideas, feeling that pleasant pull of curiosity mixed with drowsiness, perhaps you'd like to join us for more of these sleepy cosmic explorations by gently tapping that like or subscribe button. Not because you have to, but because there are so many more mysteries waiting to unfold on other quiet nights like this one. What if the speed of a light wasn't just another number in a physics textbook, but a gentle doorway into understanding how the universe really works, how it weaves space and time together into something far stranger and more beautiful than our everyday experience suggests? Tonight, we're going to explore this together, you and I, moving slowly through ideas that have captivated scientists and dreamers for over a century, ideas that started with a young patent clerk staring out a window, imagining what it would be like to ride alongside a beam of light. You see, we live our lives in a world where time seems so dependable, so constant. Every second that passes for you seems to pass the same way for everyone else. Your clock ticks at the same rate as mine, or so it appears. The minutes that carry you towards sleep tonight feel universal, shared, common to all of us breathing on this planet. But this comfortable assumption, this thing we take so completely for granted, begins to unravel when we start moving very, very fast. Not the kind of fast you experience in a car or even in an airplane, but the kind of fast that approaches the cosmic speed limit itself, 186,282 miles per second, the speed at which light itself travels through the vacuum of space. Right now, as you listen to these words, light from your screen or from the stars outside your window is reaching your eyes at this incredible speed. It's a speed so fast that if you could travel at it, you would circle the entire Earth 7.5 times in a single second. You would reach the moon in just over a second, the sun in about 8 minutes. And yet, despite this almost incomprehensible velocity, light takes years to travel between the stars, centuries to cross our galaxy, billions of years to reach us from the most distant corners of the observable universe. This speed, this cosmic constant, isn't just fast. It's the fundamental heartbeat of reality itself, the maximum rate at which any information, any influence, any change can propagate through the fabric of space. But here's where things become beautifully strange. According to Einstein's special theory of relativity, as you approach this speed, time itself begins to behave differently for you than for those you leave behind. It's not that your watch breaks or that your perception becomes confused. No, time itself, the actual flow of moments, the space between heartbeats, the duration of thoughts, all of it begins to slow down relative to the rest of the universe. And if you could somehow reach the speed of light itself, if you could match the velocity of those photons streaming through space, time would stop entirely. Not metaphorically, not poetically, but literally. No time would pass for you at all. This isn't science fiction, though it sounds like it should be. This is the actual architecture of our universe, confirmed by countless experiments, observed in particle accelerators, measured in the behavior of cosmic rays, verified by atomic clocks on fast-moving satellites. The universe really does work this way, though the speeds we achieve in our daily lives are so small compared to light speed that we never notice these effects. You could spend your entire life traveling in cars and planes and trains, and the difference in how time passes for you versus someone standing still would amount to perhaps a few millionths of a second. Barely a whisper of the profound truth that underlies all motion. Let me paint you a picture, a thought experiment that physicists have loved for generations. Imagine you have a twin, someone born at the exact same moment as you, sharing your DNA, your history, your age down to the second. Now imagine that your twin boards a spacecraft, not just any spacecraft, but one capable of traveling at speeds approaching that of light. As they accelerate away from Earth, something remarkable begins to happen. From your perspective, standing on solid ground, watching through a telescope perhaps, your twin's clock begins to tick slower. Their movements seem to slow down. If you could somehow see them clearly, you would watch them age more slowly than you. But here's the truly mind-bending part. From your twin's perspective aboard that speeding ship, everything feels completely normal. Their watch ticks at its usual rate. Their thoughts flow at their regular pace. Their heart beats its familiar rhythm. To them, it's not their time that has slowed. It's yours and everyone else's back on Earth that seems to be racing ahead. This isn't an illusion or a trick of perception. Both perspectives are equally valid, equally real. There is no universal clock against which to measure who is really experiencing time correctly. This is what physicists call time dilation, and it reveals something profound about the nature of time itself. Time, it turns out, is not the universal constant we imagined it to be. It's more like a river that can flow at different rates depending on how you move through it. Or perhaps it's better to think of it as a dimension, similar to the 3 dimensions of space we move through every day. Just as you can choose to walk north or south, east or west, up or down through space, you and everything else in the universe is always moving through time as well. But here's the beautiful, strange secret that Einstein discovered. The faster you move through space, the slower you move through time. It's as if you have a certain fixed speed through space-time itself, and you can choose to distribute that speed between movement through space and movement through time. Right now, as you lie still, listening to these words, nearly all of your motion through space-time is directed through time. You're racing toward the future at the maximum possible rate, 1 second per second from your perspective. But if you were to get up and walk across the room, a tiny, almost immeasurable fraction of your motion would shift from time to space. You would age ever so slightly slower than someone who remained perfectly still. The effect is so small at walking speed that it would take billions of years to accumulate even a second of difference. But the principle is there, quietly operating, a fundamental feature of the cosmos. As we move faster, this trade-off becomes more pronounced. At 10% the speed of light, time would pass about 0.5% slower for you. At 50% the speed of light, it would be about 13% slower. At 90% the speed of light, time would pass less than half as fast for you as for someone at rest. And as you approach closer and closer to light speed itself, time dilation becomes more and more extreme. At 99% the speed of light, time passes 7 times slower. At 99.9%, it's 22 times slower. At 99.99%, it's 70 times slower. The closer you get to that ultimate speed, the more dramatically time slows, approaching but never quite reaching a complete stop. This is why we say that time stops at the speed of light. It's not a sudden thing, like hitting a wall. It's a gradual approach to an impossible limit. Because here's another piece of this cosmic puzzle. It would take infinite energy to accelerate any object with mass to the speed of light. The faster you go, the more energy you need to go even faster, and this requirement grows without bound as you approach light speed. Only things without mass, like photons of light itself, can travel at this ultimate velocity. And for these massless particles, racing through the cosmos at the maximum possible speed, no time passes at all. Think about that for a moment. From the perspective of a photon, if such a perspective could exist, its entire journey happens instantaneously. A photon emitted from a distant galaxy billions of light years away experiences no time during its billions of years of travel to reach your eye. From its frame of reference, it is emitted and absorbed in the same instant, even though from our perspective, it has traveled across vast reaches of space and deep spans of time. The light from stars that you might see tonight, light that has traveled for years or centuries or millennia to reach you, experienced no time during that journey. It exists in an eternal now, a frozen moment stretched across the cosmos. This raises profound questions about the nature of light, of time, of existence itself. If photons experience no time, What does that mean for the information they carry? How can something change, evolve, or interact if no time passes for it? The answer lies in understanding that while no time passes in the photon's frame of reference, it still interacts with the universe from our frame of reference. It's a beautiful paradox that highlights how deeply observer-dependent our universe really is. There is no absolute truth about how much time passes, only relative truths that depend on how you're moving. Scientists have confirmed these strange truths in countless ways. They've synchronized atomic clocks, the most precise timekeepers we have, placed one on the ground and another in a fast-moving airplane, and found that less time passes for the moving clock exactly as Einstein predicted. They've observed particles called muons, created when cosmic rays strike our upper atmosphere, that should decay long before reaching the ground, but because they're moving so fast that time dilation allows them to survive the journey. They've measured the frequencies of light from moving sources and found them shifted exactly as relativity predicts. Every observation, every experiment, every test confirms that this is really how our universe works. But why? Why does the universe have this strange relationship between space and time and the speed of light? The answer seems to lie in the fundamental structure of space-time itself. You see, before Einstein, scientists thought of space and time as separate things. Space was the stage on which events occurred, and time was the universal clock that marked when they occurred. But Einstein showed us that space and time are actually different aspects of a single, four-dimensional fabric called space-time. Events don't happen in space and time, they happen in space-time, and in this four-dimensional fabric. The speed of light isn't just a speed limit, it's a conversion factor between space and time, the fundamental constant that defines how they relate to each other. It's built into the very geometry of the universe. Asking why the speed of light has the value it does is like asking why a circle has 360 degrees, or why a triangle's angles sum to 180 degrees. It's a feature of the underlying structure of reality itself. This geometric view of space-time leads to even stranger insights. Not only does motion through space affect the passage of time, but gravity does too. Einstein's general theory of relativity shows us that massive objects bend space-time around them, and this bending affects both space and time. The stronger the gravitational field you're in, the slower time passes for you relative to someone in weaker gravity. This means that time passes slightly slower at sea level than on a mountaintop, slower on Earth than in deep space, and much, much slower near a black hole than anywhere else in the universe. If you were to approach a black hole, that ultimate gravitational monster, where space and time curve so extremely that not even light can escape, you would experience something similar to approaching the speed of light. As you fell toward the event horizon, the boundary beyond which nothing can return, time would slow more and more for you relative to the outside universe. If someone far away could watch you fall, they would see you slow down, your movements becoming more and more sluggish, your clock ticking slower and slower, until at the event horizon itself, you would appear to freeze completely. From the outside perspective, you would never quite cross the event horizon. You would remain frozen at that boundary for the entire future history of the universe. But from your perspective, falling into the black hole, nothing special would happen at the event horizon. You would cross it in finite time by your clock, continuing your fall toward the singularity at the center. It's another example of how different observers can have radically different but equally valid experiences of time. There is no universal truth about when you cross the event horizon. It depends entirely on who's doing the observing. These ideas might seem like abstract physics, far removed from our daily experience, but they have practical consequences. The GPS satellites that help you navigate rely on precise timing, and their clocks run faster than clocks on Earth's surface because they are in weaker gravity and moving relative to the ground. If we didn't account for both special and general relativistic effects, GPS would accumulate errors of about 10 kilometers per day. Your phone's ability to tell you where you are depends on our understanding that time is not absolute but relative, flexible, changeable. And this flexibility of time opens up possibilities that sound like pure fantasy, but are actually allowed by the laws of physics. If you could travel at speeds close to the speed of light, you could journey to distant stars in what would feel like a reasonable time to you, even though centuries or millennia would pass on Earth. A journey to the nearest star, Proxima Centauri, 4.22 light-years away, could be completed in just a few months of your subjective time, if you could travel at 99.99% the speed of light, though 4.2 years would still pass on Earth. Push even closer to light speed, and you could traverse the entire galaxy in what feels like years or decades to you, while hundreds of thousands of years pass for those you left behind. This is sometimes called the twin paradox, though it's not really a paradox once you understand relativity. If one twin stays on Earth, while the other travels to a distant star at near light speed and returns, the travelling twin will have aged much less than the one who stayed behind. They will have literally travelled into Earth's future, skipping over years or decades or centuries of history. It's a one-way journey through time, always forward, never back, but it's genuine time travel nonetheless, allowed and described by the laws of physics we know to be true. But what about travelling at the speed of light itself? What would that experience be like? This is where we reach the boundary of what physics can tell us, because as we've seen, nothing with mass can ever quite reach that speed. But we can imagine, we can extrapolate, we can wonder, if you could somehow reach light speed, if you could match the velocity of those photons racing through space, what would you experience? From the equations of relativity, we can say that time would stop completely for you. No time would pass at all. From your perspective, you would depart and arrive simultaneously, no matter how vast the distance. You could travel to the edge of the observable universe 46 billion light-years away in zero time by your clock. Of course, billions of years would pass for the rest of the universe, but you would experience none of it. You would exist in a single eternal moment, frozen between departure and arrival. But this leads to paradoxes and problems that suggest such travel might be impossible even in principle. If no time passes for you, how can you experience anything? How can you think, observe, or even exist in any meaningful sense? Perhaps this is why the universe imposes that ultimate speed limit, why it requires infinite energy to reach light speed. Perhaps it's protecting causality itself, the basic notion that causes precede effects, that time has a direction, that the universe has a coherent history. And yet, even if we can never reach light speed ourselves, the fact that light does travel at this speed, that photons do exist in this timeless state, tells us something profound about the nature of our universe. It tells us that past, present, and future are more fluid than we imagine. It tells us that the universe has room for both, our everyday experience of flowing time and the photon's timeless existence. It tells us that time itself is not fundamental, but emergent, rising from something deeper, something we're only beginning to understand. Modern physics is pushing even further into these mysteries. String theory suggests that space-time might have more than 4 dimensions, with extra dimensions curled up too small for us to perceive. Loop quantum gravity proposes that space-time itself might be quantized, made of discrete units at the smallest scales, with profound implications for what happens at extreme speeds and energies. And some theories even suggest that time itself might be emergent, not fundamental, arising from deeper timeless laws in a way we don't yet comprehend. There's something deeply contemplative about light, isn't there? Right now, as you rest there, photons that have travelled vast distances are reaching you. Some from the lamp in your room, created just microseconds ago. Some from the sun, 8 minutes old. Some from the stars, years or decades or centuries old. And if you're somewhere dark enough to see the faint band of the Milky Way, some of that light has been travelling for thousands of years to reach your eyes in this exact moment. Each of these photons, from its own perspective, experiences no time during its journey. The photon from your lamp and the photon from a distant star both exist in their own eternal now, despite the vast differences in their travel time from our perspective. They are messengers from the timeless heart of the universe, bringing us information about distant places and ancient times, yet experiencing none of the duration of their journey. And we, made of matter, made of particles with mass, are forever barred from that timeless realm. We are creatures of duration, of sequence, of change. We exist in time, are defined by time, are arguably made of time in some deep sense. Our thoughts, our heartbeats, our very atoms vibrate with the passage of time. We can approach that timeless realm of light speed, get arbitrarily close to it with enough energy, but we can never quite reach it. We are eternal observers of the timeless, forever separated from it by the unbridgeable gap between massive and massless, between time and timelessness. Yet in another sense we are intimately connected to that realm. The electromagnetic force that holds our atoms together is mediated by virtual photons, timeless particles flitting in and out of existence. The light by which we see, the radio waves that carry our communications, the infrared radiation by which we warm ourselves. All of these are manifestations of that timeless realm intersecting with our time-bound existence. We are, in a very real sense, constantly interacting with timelessness, even as we remain embedded in time. Consider your own body for a moment. The atoms that make you up are mostly empty space, with electrons orbiting nuclei at distances that, scaled up, would be like planets orbiting the sun. And the forces that hold these atoms together, that allow them to form molecules, that enable the chemistry of life itself, are mediated by photons. Virtual photons, quantum fluctuations of the electromagnetic field, constantly exchange between charged particles. These photons, existing in their timeless state, are what allow you to exist as a coherent entity in time. You are, in a sense, a conversation between time and timelessness, matter and light, duration and eternity. The warmth you feel from a blanket, the pressure of your pillow, the soft resistance of the mattress beneath you. All of these sensations arise from electromagnetic interactions, from the timeless exchange of photons between atoms. Even as you experience the steady flow of time, counting breaths, feeling your heartbeat, you're supported by a foundation of timeless interactions. It's as if the universe has woven together the temporal and the eternal into the fabric of everyday experience. As we contemplate these ideas, drifting deeper into the mysteries of space and time, it's worth pausing to appreciate the profound beauty of what physics has revealed. A century ago, before Einstein, we thought time was absolute, unchanging, the same for everyone everywhere. Now we know it's relative, flexible, personal. We know that motion and gravity can stretch and compress time like taffy. We know that the universe has a maximum speed, not just for objects, but for causation itself. We know that at this speed, time stops entirely, that photons exist in an eternal now even as they trace paths through space that we measure in years. These aren't just abstract ideas or mathematical curiosities. They're features of the universe you inhabit right now. As you lie there, you're moving through time at your own particular rate, slightly different from someone at a different altitude or latitude, slightly different from someone in motion relative to you. These differences are tiny, imperceptible, but they're real. You're experiencing your own personal flow of time, your own unique path through the four-dimensional fabric of space-time. And if time can slow, can nearly stop, what does this tell us about its nature? Is time fundamental, or does it emerge from something deeper? Is the flow of time real, or is it an illusion created by consciousness moving through a static, four-dimensional space-time? These are questions that physicists and philosophers still debate. Questions that touch on the nature of existence itself. The fact that time can dilate, can differ between observers, suggests that our everyday understanding of time as a flowing river, carrying us from past to future, might be incomplete, might be just one limited perspective on something far more profound. Some physicists have suggested that the entire history of the universe, past, present, and future, exists as a static four-dimensional structure called the block universe. In this view, time doesn't flow. Rather, we experience a flow as our consciousness traces a path through this fixed structure. The past still exists, the future already exists, and the present is just our current location in this vast four-dimensional map. It's a view that emerges naturally from relativity, from the fact that different observers disagree about what constitutes now at distant locations. If you and someone in a distant galaxy could somehow communicate instantaneously, you would disagree about what time it is in each other's location. What you consider to be happening now in that distant galaxy might be what they consider their past or future, depending on how you're each moving. This relativity of simultaneity suggests that there is no universal now, no single moment that encompasses the entire universe. Instead, each observer has their own now, their own slice through space-time, and these slices can be oriented differently for different observers. This leads to profound questions about free will, about whether the future is determined or open. If the future already exists in the block universe, are our choices real, or are we simply playing out a script already written in the geometry of space-time? Different physicists have different views, and the question remains open, a deep mystery at the intersection of physics and philosophy. But what's clear is that time, this thing we take so for granted, is far stranger and more mysterious than our everyday experience suggests. Yet for all its strangeness, there's something comforting about the reliability of physical law. No matter how weird the universe gets, no matter how much it defies our intuitions, it follows consistent rules. The speed of light is the same for all observers. Time dilates in precisely predictable ways. The universe, for all its mystery, is lawful, mathematical, comprehensible. We can write equations that describe how time behaves at any speed in any gravitational field. We can predict exactly how much time will pass for a spacecraft traveling to distant stars. We can calculate the age difference between twins separated by relativistic travel. This lawfulness extends even to the edges of what we understand. Black holes, those regions where gravity becomes so strong that space and time break down, still obey precise mathematical rules. The event horizon forms at exactly the radius predicted by Einstein's equations. Time dilation increases smoothly and predictably as you approach it. Even at the singularity where our current theories break down, we expect that some deeper theory, some quantum theory of gravity, will eventually describe what happens in terms of consistent mathematical laws. There's a deep beauty in this, isn't there? That we, tiny conscious beings on a small planet orbiting an ordinary star, can discover and understand the laws that govern time itself throughout the cosmos. That we can predict how time behaves in conditions we'll never experience, at speeds we'll never achieve, near objects we'll never visit. Our minds, operating at the slow pace of biological thought, can comprehend the timeless realm of light, can calculate what happens as we approach that ultimate speed. As you drift here in the darkness, perhaps getting sleepier as we explore these cosmic mysteries, consider that your ability to understand these things is itself a kind of miracle. Your brain, operating through electrochemical signals traveling at mere meters per second, infinitesimal compared to light speed, can nonetheless grasp truths about the universe at its most extreme scales. You can imagine what it would be like to travel at near light speed, even though you'll never experience it. You can understand that time stops for photons, even though you'll never be one. This capacity for abstract understanding, for grasping realities far beyond our direct experience, might be one of the most remarkable phenomena in the universe. It's as if consciousness itself is a bridge between the time-bound and the timeless, able to exist in duration while comprehending eternity. We are local manifestations of the universe, becoming aware of itself, discovering its own laws, contemplating its own nature. And in contemplating time dilation, in imagining travel at light speed, we're really confronting some of the deepest questions about existence. What is time? Why does it have the character it does? Why can it dilate but only in one direction, always forward, never back? Why is there a maximum speed at all? These questions lead us to the very foundations of physics, to questions about why the universe exists and why it has the laws it does. Some physicists speculate that our universe is one of many, perhaps infinite universes in a vast multiverse, each with different physical laws, different constants, different relationships between space and time. In some of these universes, perhaps there is no maximum speed, no special velocity at which time stops. In others, perhaps time works differently altogether, or doesn't exist at all in any form we would recognize. Our universe, with its particular speed of light, its particular way of weaving space and time together, might be just one example of what's possible. But even if that's true, even if we're just one universe among countless others, there's something special about the laws we've discovered. They allow for complexity, for structure, for life and consciousness. The fact that time can dilate but not stop entirely for massive objects means we can have both change and stability. The fact that light travels at a finite speed means causality is preserved, that the universe has a coherent history. These features, these particular laws, allow for a universe where beings like us can exist and wonder about our existence. As we approach the deeper hours of night, as your breathing perhaps becomes slower and more regular, let's return to that central image. You accelerating toward the speed of light, time slowing around you like honey, like thick syrup, like the universe itself is reluctant to let you reach that ultimate boundary. With each increment of speed, time passes a little slower for you. The stars ahead shift blue, compressed by your motion. The stars behind shift red, stretched out as you race away. The entire universe begins to distort around you, space and time bending to accommodate your motion. At 99.9999% the speed of light, time passes 224 times slower for you. A day of your time corresponds to more than 7 months passing on Earth. Your heartbeat, steady and regular to you, would seem to distant observers to occur only once every few minutes. Your thoughts, quick and clear to you, would appear glacially slow to the outside world. You would be living in a different time stream, a different layer of temporal reality, even as you occupy the same space as the rest of the universe. Push even closer to light speed, to 99.9999% perhaps, and the effect becomes even more extreme. Now time passes thousands of times slower for you. Years pass on Earth for every day you experience. You could travel to the galactic center and back in what feels like months, returning to find centuries have passed on Earth. You would be a time traveler, not through any exotic physics or wormholes or time machines, but simply through motion, through the fundamental way that space and time are connected. But always, always that final barrier remains. No matter how much energy you pour into acceleration, you can never quite reach light speed. You can get arbitrarily close, 99.99999%, 99.99999%, as many nines as you like, but never 100%. The universe protects that boundary with infinite jealousy, requiring infinite energy to cross it. It's as if light speed is not just a velocity but a fundamental category boundary, separating the realm of matter from the realm of light, the realm of time from the realm of timelessness, and perhaps that's as it should be. Perhaps the universe needs both realms to function as it does. The timeless realm of light allows for instantaneous quantum correlations, for the electromagnetic forces that hold matter together, for the cosmic speed limit that preserves causality. The time-bound realm of matter allows for change, for growth, for evolution, for the complexity that leads to life and consciousness. We exist at the intersection of these realms, made possible by both, unable to fully inhabit either. Think about the photons entering your eyes right now if they're open, or the ones that were entering them before you closed them. Each photon has its own history, its own journey through space, yet experiences none of it. A photon from your ceiling light and a photon from a galaxy billions of light years away both experience their entire journey in zero time. From their perspective, they are emitted and absorbed, simultaneously, existing for a single timeless instant that we, from our time-bound perspective, measure as nanoseconds or billions of years. This raises a beautiful paradox about observation and consciousness. We perceive the universe through light, through these timeless messengers that experience no duration. Our entire picture of the cosmos is built from information carried by entities that exist outside of time. Every image of a distant galaxy, every observation of a far-off star, every detail we know about the universe beyond Earth comes to us via photons that experienced no time during their journey. We are time-bound beings constructing a picture of the universe from timeless messengers, using duration to understand the durationless. And this extends beyond just visible light. Radio waves from distant pulsars, X-rays from black hole accretion disks, gamma rays from cosmic explosions, infrared radiation from stellar nurseries. All of these are forms of light, all traveling at that ultimate speed, all existing in that timeless state. The entire electromagnetic spectrum from the longest radio waves to the shortest gamma rays consists of these timeless photons racing through space, experiencing no time, yet carrying information about events separated by vast durations from our perspective. Even gravity, we now know, propagates at the speed of light. When massive objects accelerate, they create ripples in space-time itself, gravitational waves that travel outward at light speed. These waves, first directly detected in 2015, carry information about cosmic catastrophes, colliding black holes, merging neutron stars, perhaps even the Big Bang itself. And like electromagnetic waves, they travel at that special speed where time stops, where cause and effect kiss at the boundary of the possible. This universality of the speed of light, the fact that it's not just about light but about the fundamental structure of space-time, tells us something deep about our universe. That speed, 297.92, 458 meters per second, is woven into the fabric of existence itself. It's the speed at which causes propagate to effects, the maximum rate at which any influence can travel, the conversion factor between space and time in the geometry of space-time. It's not arbitrary, it's structural, fundamental, necessary. As you lie there, perhaps feeling heavier, more relaxed, more ready for sleep, consider that you are embedded in this structure. Your body, your thoughts, your very existence depends on the interplay between space and time, matter and light, duration and timelessness. You're a pattern that persists through time, maintained by timeless interactions. You're a slow eddy in the flow of entropy, a temporary gathering of atoms that somehow becomes aware of its own temporary nature. The question, does time stop when you hit the speed of light, has led us deep into the nature of reality itself. We've seen that yes, according to our best understanding of physics, time does indeed stop at light speed. But we've also seen that this stopping is not an event but a limit, not a destination, but a boundary that defines the very structure of space-time. We've explored how this connects to the finite speed of causation, the relativity of simultaneity, the possibility of time travel, the nature of observation, and the deep mystery of why the universe has the particular laws it does. And through it all, we've glimpsed something beautiful, a universe that is far stranger than our everyday experience suggests, yet lawful and comprehensible. A cosmos where time can stretch and compress, where simultaneity is relative, where photons exist in eternal instants, yet where we can still make sense of it all through mathematics and physics. A reality that challenges our intuitions yet rewards our curiosity with deep truths about the nature of existence. You know, there's something profoundly peaceful about these cosmic truths, isn't there? The universe continues its patient work whether we understand it or not. Light continues to travel at its constant speed. Time continues to dilate according to precise laws. The fabric of space-time continues to curve and flex around massive objects. These processes don't require our awareness or understanding. They simply are, have been for billions of years, will be for billions more. Right now, as you rest there, you are participating in this cosmic dance. The Earth is spinning, carrying you through space at hundreds of miles per hour, though you feel perfectly still. The Earth is orbiting the Sun at about 67,000 miles per hour. The solar system is orbiting the galactic center at about 514,000 miles per hour. The Milky Way is moving through space at about 1.3 million miles per hour. All these motions add up, creating your total velocity through space-time, affecting ever so slightly how fast time passes for you compared to someone elsewhere in the universe. But these speeds, impressive as they sound, are tiny compared to the speed of light. Even our fastest spacecraft barely reach 0.02% of light speed. We are, for all practical purposes, at rest compared to the cosmic speed limit. We experience time at very nearly its maximum rate, aging 1 second per second, living in what physicists sometimes call the rest frame of the universe. We are, in a sense, temporal homebodies, experiencing duration at its fullest, while the photons race past us in their timeless journeys. Yet even from our slow, time-bound perspective, we can understand and appreciate the larger structure. We can calculate how time would behave if we could travel faster. We can observe the effects of time dilation in particle accelerators and cosmic rays. We can synchronize GPS satellites by accounting for relativistic effects. We can detect gravitational waves from colliding black holes billions of light years away. We are local observers who have discovered universal truths, time-bound beings who have glimpsed the timeless. As sleep perhaps begins to pull at you more insistently, as your thoughts become softer and more dreamlike, consider this final mystery. Consciousness itself seems to exist at the boundary between time and timelessness. Our awareness is clearly embedded in time. We experience duration, remember the past, anticipate the future. Yet consciousness also seems to transcend individual moments, creating a sense of continuity, of persistent self that bridges across the flow of time. We are somehow both in time and observing time, subject to duration and aware of duration. When you dream tonight, time will behave strangely. Dreams that seem to last hours might occur in minutes of real time. You might experience past, present, and future jumbled together in ways that make perfect sense in the dream, but seem impossible upon waking. In some sense, consciousness in dreams approaches its own version of time dilation, stretching and compressing subjective duration independently of the clock on your nightstand. And who knows? Perhaps in your dreams tonight, you'll experience something like what it might feel like to approach light speed. Perhaps you'll dream of racing past stars, watching them blur into streaks of light, feeling time slow to a crawl around you while you remain in your own bubble of normal time. Perhaps you'll dream of riding alongside a beam of light, experiencing that impossible perspective where all distances collapse to zero and all durations vanish into a single eternal moment. Or perhaps you'll simply rest, carried by the ordinary flow of time at 1 second per second, aging at the standard rate along with everyone else on this spinning planet. There's something comforting in that too, in sharing a common time stream with billions of other conscious beings, all experiencing duration at roughly the same rate, all carried together toward tomorrow at the stately pace of Earth's rest frame. The universe doesn't care whether we're awake or asleep, whether we understand its laws or remain ignorant of them. It continues its vast processes regardless. Stars continue to shine, their photons racing through space at light speed. Galaxies continue their stately rotation, gravity propagating at light speed to hold them together. Black holes continue to bend space-time around them, creating regions where time dilation becomes extreme, and throughout it all, the cosmic speed limit remains inviolate, the boundary between time and timelessness, the fundamental constant that shapes the structure of reality itself. Somewhere out there, right now, cosmic rays are striking our atmosphere, their time dilated so much that they survive journeys that should be impossible. Somewhere, particles in an accelerator are approaching light speed, their time slowing relative to the laboratory. Somewhere, photons that have travelled for billions of years are just now reaching telescopes, carrying information about the early universe, having themselves experienced no time during their vast journey. And here you are, nested in your own local pocket of space-time, experiencing duration at your particular rate, neither racing toward the future, nor frozen in an eternal now, but flowing along at the pace determined by your motion and gravity. You're exactly where you need to be in the cosmic scheme, experiencing time exactly as you should, part of the vast pattern that includes both the time-bound and the timeless, both matter and light, both the slow and the impossibly fast. The question we began with, does time stop when you hit the speed of light, has revealed itself to be a doorway into the deepest mysteries of existence. And like all good mysteries, it leaves us with more questions than answers, more wonder than certainty. Why does the universe have a maximum speed? Why is it the particular value it is? Why does time dilate rather than space contracting? Or rather, why do we perceive it as time dilating when both space and time are really transforming together? These questions lead us to the edge of what we know, to the boundary between understood and mysterious, between the mapped and the unexplored. But for tonight, perhaps, it's enough to simply appreciate the beautiful strangeness of it all, to know that we live in a universe where time is flexible, where the speed of light is absolute, where photons exist in timeless instants while we experience the steady flow of duration. To understand that these aren't just abstract ideas, but the actual architecture of reality, the framework within which all existence unfolds. As your eyes grow heavier, if they aren't already closed, as your breathing deepens and slows, you remain part of this grand structure. The same laws that govern light speed and time dilation govern the atoms in your body, the neurons in your brain, the very thoughts that are perhaps now becoming softer and more dreamlike. You're not separate from the cosmos, but woven into it, made from it, an expression of its deep laws and fundamental constants. And in the silence between your breaths, in the pause between heartbeats, something of that cosmic timelessness touches you. Not the full stopping of time that occurs at light speed, but a gentle slowing, a peaceful approach to rest. Sleep itself is a kind of time dilation, isn't it? Hours pass that feel like moments, or moments that feel like hours. The regular clock time of the waking world gives way to the elastic, subjective time of dreams and deep sleep. Tonight, as every night, you'll experience your own version of temporal strangeness. You'll close your eyes in one moment and open them in another, with hours of clock time having passed but little subjective experience of duration. You'll dream, perhaps, and in those dreams time will behave according to its own rules, neither the strict time of physics nor the regular time of waking life, but something more fluid, more personal, more mysterious. And all the while, as you sleep, light will continue its timeless journey through space. Photons from distant stars will rain down through your roof, passing through you without interaction, continuing their eternal instant of existence. Gravitational waves from distant cosmic events will pass through the Earth, stretching and compressing space-time by infinitesimal amounts, carrying information about catastrophes that occurred before our solar system formed. The universe will continue its patient work, indifferent to our sleep or waking, yet somehow including us in its vast processes. In the morning, when you wake, you'll have aged by exactly the amount of time that passed on your clock, modified by tiny, imperceptible amounts due to your motion through space and your position in Earth's gravitational field. You'll have travelled toward the future at almost exactly 1 second per second, the standard rate for matter at rest. You'll have participated in the cosmic dance of space-time without even knowing it, your very existence a testament to the deep laws we've explored tonight. But for now, in this moment between waking and sleep, you can rest in the knowledge that the universe is far stranger and more wonderful than our everyday experience suggests. That time itself is not the rigid framework we imagine, but something flowing and flexible. That light exists in a timeless realm we can understand but never experience. That we are patterns of matter and energy, persisting through time, made possible by the interplay of the temporal and the eternal. The question of whether time stops at light speed has taken us on a journey through some of the deepest ideas in physics, from Einstein's relativity to the nature of space-time, from the perspective of photons to the possibility of time travel, from the abstract mathematics of physics to the concrete reality of GPS satellites. We've seen that the answer is yes, time does stop at light speed, but we've also seen that this simple answer opens up vast territories of mystery and wonder. And perhaps that's the most beautiful thing about physics, about science, about our quest to understand the universe. Every answer we find reveals new questions. Every mystery we solve opens up deeper mysteries. The universe is not a puzzle to be completed, but an endless source of wonder, offering new perspectives and insights to anyone willing to look closely and think deeply. As you drift now towards sleep, carried by the ordinary flow of time in your rest frame, remember that you are part of something vast and strange and beautiful. You are made of atoms forged in the hearts of stars, held together by forces mediated by timeless photons, experiencing duration while surrounded by the timeless. You are a temporary arrangement of matter that has somehow become aware of its own temporary nature, capable of contemplating eternity even while embedded in time. And, in that contemplation, in that capacity to wonder about light speed and time dilation, about the structure of space-time and the nature of existence, you touch something profound. You participate in the universe's self-awareness, its ability to know itself through conscious beings like you. You are the cosmos looking back at itself, discovering its own laws, marveling at its own structure. So rest now, peaceful in the knowledge that the universe continues its work all around you. Light continues to race through space at its cosmic speed limit. Time continues to flow at its various rates for different observers. The laws of physics continue to operate with their quiet reliability. And you, wonderful pattern of matter and consciousness that you are, continue your journey through space-time at your own particular pace, neither rushing toward light speed nor frozen in place, but moving gently toward tomorrow at the perfect rate of 1 second per second. In the quiet depths of space, photons that left distant galaxies billions of years ago are just now arriving at Earth, completing journeys that from their perspective took no time at all. Near black holes, time crawls nearly to a stop. In particle accelerators, subatomic particles experience severe time dilation. And here, in your room, in your bed, you experience time at its most familiar rate. The pace of heartbeats and breathing, of thoughts and dreams. All of these are equally valid perspectives on time, equally real manifestations of the strange relationship between space, time, and the speed of light. There is no privileged frame of reference, no absolute clock against which all others can be measured. There is only the relative dance of observers, each experiencing their own flow of time, each valid in their own frame, all connected by the universal constant of light speed. And as you finally let go, releasing the last threads of waking thought, you can rest in the simple beauty of that truth. The universe has room for all perspectives, all time frames, all experiences of duration. From the timeless photon to the slowly aging star, from the fast-moving cosmic ray to the patient Earth, everything has its place in the cosmic order. And you, right here, right now, drifting into sleep, are exactly where you belong in that order, experiencing time exactly as you should, part of the endless dance of space and time, matter and light, duration and eternity. Sleep now, knowing that tomorrow you'll wake having travelled through time in the most ordinary and extraordinary way, carried by the patient rotation of the Earth, the steady orbit around the Sun, the stately procession around the galaxy. You'll have aged by hours while photons have crossed vast distances in their timeless state. You'll have participated in the cosmic dance without even trying, your very existence a testament to the beautiful strange laws that govern our universe. And perhaps, in your dreams, you'll touch something of that timeless realm. Perhaps you'll experience the fluid time of sleep, where moments stretch and compress, where past and future blend together, where the ordinary rules of duration give way to something more mysterious. Perhaps you'll dream of flying through space, approaching that ultimate speed, feeling time slow around you while you remain in your bubble of normal time. Or perhaps you'll simply rest, deep and dreamless, carried by the flow of time without conscious awareness, trusting in the reliability of physical law to bring you safely to morning. Either way, you'll be participating in the grand mystery of time, the strange truth that duration is not fixed but fluid, not absolute but relative, not separate from space but woven together with it into the fabric of space-time itself. The universe continues its quiet work all around you. Stars burn their nuclear fuel, converting matter to energy, sending photons on timeless journeys through space. Gravity waves ripple outward from cosmic catastrophes, carrying information at light speed. Particles in cosmic rays experience extreme time dilation as they race through the galaxy. And you, nested in your local frame of reference, experience it all from your own unique perspective, your own particular flow through time. This is the gift of consciousness, isn't it? To be aware of time while embedded in it, to contemplate the timeless while experiencing duration, to understand even partially the vast structure of space-time while occupying just a tiny portion of it. You are the universe understanding itself, discovering its own laws, contemplating its own mysteries. And as you drift into sleep, you carry that understanding with you, not as conscious thought, but as something deeper, a felt sense of belonging to something vast and strange and beautiful. You are part of the cosmic order, subject to its laws, made possible by its constants, woven into its fabric. The same physics that stops time at light speed allows you to exist, to think, to wonder, to sleep, to dream. In the end, the question, does time stop when you hit the speed of light, reveals itself to be about more than just physics. It's about the nature of existence, the structure of reality, our place in the cosmos. It's about the beautiful strangeness of a universe where time can dilate, where simultaneity is relative, where photons exist in timeless instants. It's about the wonder of being conscious beings capable of discovering these truths, of understanding our own temporal nature. And now, as this journey through ideas comes to its close, you can let go of trying to understand, trying to grasp, trying to hold on to concepts. You can simply rest in the wordless knowledge that you belong here, that you are part of the grand pattern, that the universe includes you in its vast processes. The same laws that govern light and time govern your sleeping and waking, your breathing and heartbeat, your very existence. Time continues its patient flow around you, neither stopped as at light speed nor frozen as near a black hole, but moving at its ordinary pace, carrying you gently toward tomorrow. And in that ordinary flow is its own kind of magic, its own deep mystery. For what is consciousness but time made aware of itself? What is sleep but a different way of experiencing duration? What are dreams but consciousness playing with time, stretching and compressing it, exploring possibilities that waking physics doesn't allow? Rest now in the embrace of physical law, held by gravity, carried through time, surrounded by the electromagnetic forces that hold your atoms together. You are safe in the reliability of the universe, in the constancy of its laws, in the patient working of its processes. The same physics that we have explored tonight surrounds you, supports you, makes you possible. And as you drift into sleep, into that realm where time behaves differently, where the ordinary rules relax their grip, remember that you remain part of the cosmic order. Whether awake or asleep, whether conscious or dreaming, you are woven into space-time, participating in its grand patterns, subject to and exemplifying its deep laws. The photons continue their timeless journeys. The stars continue their nuclear burning. The galaxies continue their stately rotation. And you continue your path through space-time, experiencing duration at your particular rate, embedded in the cosmic flow, part of the endless dance of matter and energy, space and time, the temporal and the eternal. Sleep comes now like a gentle tide, washing over conscious thought, carrying you into its own realm where time flows differently. And in that transition, in that letting go, you touch something of the mystery we've explored tonight. The boundary between waking and sleeping is like the boundary between time-bound and timeless, a horizon that defines two different realms of experience. Let go now. Let sleep take you. Trust in the continuity of physical law to carry you through the night and bring you safely to morning. The universe continues its patient work whether you're conscious of it or not. Time flows at its various rates throughout the cosmos. Light maintains its constant speed. And you, wonderful temporary pattern of consciousness that you are, can rest in the knowledge that you belong here, that you're meant to be here, that your very existence is a celebration of the physical laws that make consciousness possible. In the silence between stars, in the hush between heartbeats, in the pause between breaths, the universe continues its quiet work. And you are part of that work, part of that silence, part of that continuing. Sleep now, held by the same forces that hold the stars in their courses, carried by the same time that carries light across the cosmos, nested in the same space-time that encompasses all existence. And as you drift into sleep, you remain part of this quiet universe, wrapped in its laws, carried by its processes, gently, peacefully, softly into the night, where time flows in its own mysterious way, where consciousness touches something beyond the ordinary, where you can rest in the wordless knowledge that you are exactly where you belong, in the vast, strange, beautiful cosmos that surrounds and includes you. The question of whether time stops at light speed has brought us full circle, from wondering about photons to wondering about consciousness, from the physics of the universe to the mystery of our place within it. And now, as sleep finally claims you, you can let all these ideas go, let them dissolve into the peaceful darkness, knowing that the universe continues its patient work, that time continues its various flows, that you remain part of it all, even in sleep, even in dreams, even in the quiet depths where conscious thought gives way to something deeper, older, more fundamental. Rest now. Sleep now. Dream now if dreams come, or simply rest in dreamless sleep, carried by time at its ordinary rate, held by the laws of physics that never sleep, never rest, never stop their quiet work of maintaining the cosmos. You are safe in their constancy, held in their reliability, carried by their patient operation toward whatever tomorrow brings. And in the morning, when you wake, you'll have travelled through time in the most ordinary way, at 1 second per second, while somewhere in the universe photons continued their timeless journeys. Particles approached light speed in cosmic rays and accelerators, and the grand dance of space-time continued its eternal rhythms. You'll have participated in it all simply by existing, simply by sleeping, simply by being a conscious pattern of matter capable of wondering about time and light and the strange, beautiful universe we inhabit. But for now, just rest, just breathe, just let go into sleep, into that realm where time behaves according to its own rules, where the physics of dreams takes over from the physics of waking life, where you can float free from the ordinary constraints of duration and experience time in all its fluid, mysterious possibility. The universe continues, time flows, light races through space at its constant ultimate speed, and you, drifting now into sleep, remain part of it all, forever and always, a unique perspective on existence, a particular flow through time, a consciousness capable of contemplating the very laws that make consciousness possible. Rest now in that knowledge, sleep now in that peace, dream now in that vast and quiet wonder as you drift gently, slowly, softly into the timeless realm of sleep, carried by the patient flow of time, held by the eternal laws of physics, into the peaceful darkness where all questions dissolve into the simple, profound fact of existence itself.